Have you ever looked at one of those incredible humanoid robots and just wondered, how? How does it go from being a bunch of wires and metal to a machine that can walk and think? Well, you're in the right place. We're going to break down how it all works, and it starts with a field called physical AI. So, what does it actually take to build a robot that doesn't just, follow a script, but can genuinely see, understand, and move through our messy, unpredictable world? It turns out the answer is a fascinating mix of hardware, software, and a whole new way of thinking about intelligence itself. And that new way of thinking? It's called physical AI. For years, AI has been this powerful brain living inside a computer. Physical AI is all about giving that brain a body, giving it eyes, hands, maybe some legs, so it can actually experience and learn from the physical world, just like we do. It's about creating a mind and a body that can act together. Okay, so how does this actually work in practice? Well, building a physical AI isn't just one single giant challenge. It's really about mastering three core technologies. Let's break down these three pillars that every single modern humanoid robot is built on. Yep, getting these three areas to work together in harmony is the whole game. So let's start with the absolute foundation of it all. First up is ROS2, which stands for Robot Operating System. Now, think about your laptop. Its operating system manages the keyboard, the screen, the Wi-Fi, all the different parts, so they can work together. ROS2 is exactly that for a robot. It's the digital nervous system that lets the cameras, motors, and sensors all speak the same language. Without it, you just have a very expensive pile of parts that can't communicate. The second pillar is simulation. Look, you wouldn't test a brand new jet engine by strapping it to a passenger plane on its very first go, right? Same idea here. You don't test a pricey, complex robot in the real world right away. You use virtual environments to run thousands of tests, letting the robot fall, crash, and learn in a digital sandbox where nothing gets broken. It's a game changer for development speed and safety. And pillar number 3, of course, is the brain, AI integration. This is where the magic really happens. We're talking about toolkits like NVIDIA Isaac that provide the complex algorithms for things like recognizing objects and navigating a room. And this isn't just about going from point A to point B. It's about the robot seeing a chair, understanding that it's a chair, and then figuring out all on its own how to walk around it. And here's the crucial part. You can't have one of these without the others. They're completely intertwined. The AI brain is trained in that virtual simulation, and the whole shebang is run and managed by the ROS2 operating system. Get these three working together, and you've got the foundation for a truly modern robot. Okay. So we've got the technology. But technology is just a tool, right? It's useless without people who know how to use it. So who are the pioneers in this space? And what does their journey actually look like? What's so incredible about this moment in time is that this knowledge isn't locked away in some elite research lab anymore. The path to building these kinds of real-world systems is open to pretty much everyone, from students just starting out, to researchers pushing the boundaries, to seasoned professionals who want to lead the next wave of tech. And the way people are learning this stuff is incredibly practical. We're not talking about just reading textbooks. It starts with guided tutorials, then moves into studying how experts solved actual problems, and it all leads to you building your own projects. It's a direct path from learning something to actually doing it. And the end goal here is incredibly ambitious, but it's totally achievable. The whole idea is to empower a new generation of builders with the skills to create advanced humanoid robots, literally from scratch. This isn't just about tweaking code, it's about genuine invention. So let's zoom out for a second and bring this all home. Why does mastering this stuff matter so much right now? And what does the future really hold? Well, for one, this is not some far-off futuristic idea. It's happening as we speak. A massive community is growing around this, with thousands of students and professionals already deep into learning the skills that are going to define the next decade of technology. And honestly, this is the most important point of all. The future of robotics won't be written in academic papers alone. It's going to be built piece by piece, line of code by the people who can get their hands dirty and figure out how to make these complex systems actually work in our world. So that's where we stand. The tools are here. The operating systems, the virtual sandboxes, the AI frameworks, they are more powerful and accessible than they have ever been. All the pieces are on the table. The only question left is, what will you build?